API, Application Programming Interface. Despite the fact that API has become quite omnipresent in the last decade, many people are still afraid of this definition and they reluctantly talk about it. On the question, what do you think API is? They only say like, yeah, I understand, it helps for applications to communicate, it's application programming interface, but they don't go in depth because they are interested in the definition, but at the same time they're at some point afraid of it. During this video we'll be looking at what API is, its features, why we have APIs, more specifically which problem API solves, and of course different types of API. To start with, you might see that the title on my whiteboard is Web API. Web API is slightly different from the general API because Web APIs focus on web applications only. However, web applications is the most common usage of the API. So we'll start from the general understanding of what API is, and then we'll slowly go into Web API specific curriculum. Web API, Application Programming Interface. So looking at the word itself, you would think, is it an interface? And the answer is no. API is not an interface. API is a set of rules that help applications to communicate. Imagine this situation. It's World War II. It's 1944, and in the army, the soldiers and commanders, they communicate using the shorter language. Sometimes they even, in some armies, for example, Slavic armies, etc., they use swear words to communicate everything faster. Whenever there is a battle and soldier needs to pass something through using the phone line and etc. to their commanders, they don't say, "Dear commander, I hope my call finds you well," etc., etc. No. They use predefined set of expressions in order to deliver the message very fast. It's crucial how fast the message should be delivered in order right decisions to be made on the battleground. So API is basically the same. It's set of rules. Imagine you have an application A and you're building it for companies to use, for different companies. And these companies, in their environment, they have hundreds of different applications and they want your application to work with application B and application C. Another company would like your application A, to work with application D, application E. So how do you do that? So you have this A application, at some company it has to work with applications B and C, and at another company it needs to work with application E and D. In order to solve this problem, API comes into place. So API solves the problem. It basically enables applications to communicate. It's a set of rules that enable application A to communicate with any other application, given that this set of rules is followed. So it's a communication language and set of rules that helps applications to communicate. Once your application supports APIs, you don't care which applications company wants it to communicate with. You just ship your application and you say, you know what, these are the APIs of this application, these are the rules, API protocol that it supports, and feel free to use my application in conjunction with others. With the set of rules and communication language comes the data exchange. So APIs, they support the data exchange between applications. One quick example. You go on your government website in order to find the hospital that is closest to you. You put your postcode in and then government website lists hospitals. And they say, so this hospital is 1.6 miles away. This hospital is 2 miles away. So they are using APIs in order to fetch the data from the map applications, from Google Maps. They're using these APIs in order to get this distance related information. How do they do that? On the background, when you send that request in order to get the distance, they use the set of rules, the API set of rules. You might see the example lines on the screen now. They usually send the one-liner to the map applications to fetch that specific information. They need that specific information from your postcode to the hospital. And that's how they list it. It would be unreasonable to assume that all applications that we use have all information that they need. No. Instead, in the background, they use APIs to fetch information. So for example, most common APIs is the Twitter or X API, when you see the Twitter or X posts embedded in other applications. It can be YouTube API, it can be Google API, or for example, when our weather apps, we have numerous weather apps. So here in the UK, I use Apple Weather app, and then I use BBC Weather app. So all these weather apps don't have their own forecasting teams working on the weather. There are no hundreds of teams looking at the reports and analyzing the weather. No, there are just a couple of teams, maybe even one of two teams that prepare forecasts. And the weather apps are using APIs, then send the basically lines following the rules and ask for that information. They fetch that information from the forecasting agencies and they show it to you on weather applications. So API is set of rules, it's communication language, and it provides the data exchange in order to build the efficient applications. Imagine you're browsing through an application and you're trying to access one of the functions of applications. For example, you're looking for a new house and you have kids, so you're interested in knowing which schools this house is close to. And then the property apps usually show you. So for example, your house is close to school number 14. So your kids will go there probably if you buy that house. Instead, if the property application is not using the APIs, it says, you know what, go to Google Maps, this is the postcode of the house, and check yourself which schools are there. Because it doesn't use APIs to fetch that information. And it's very costly to host all the maps around the UK to show you which schools are closest. So not all web servers can do that, and it's unreasonable to use the resources and the servers to store all information we need. In the same way, so for example, if you go to ChatGPT and you ask ChatGPT, can you please chronologically list the battles that happened in Europe in 16th century. ChatGPT doesn't have this information stored in its servers necessarily. ChatGPT will be fetching that information from around the internet. It can be Wikipedia or any other sources. In the background, it can do the cross-checking, but it will be using APIs to fetch that information from different web applications. That's why the applications that use APIs, they are efficient applications. They can communicate with each other. You can see it as a diplomatic application. A diplomatic country can form relationships with other countries, and that's why it can establish trading rules, it can establish good relationships which help countries to survive, like countries in the European Union, how they created one union for many European countries realistically. So API can be also associated with good diplomatic relationships that your application can build. Web API specifically uses HTTP methods, and that's how the name web comes. It's for web applications, and the most common, the lifeblood of the web applications is the HTTP protocol. Don't forget to watch my video on HTTP protocol. It's very, very useful. That's the main differentiating point of web API, the fact that it uses HTTP methods. And methods of HTTP, let me remind you quickly, for example, get, post, options, delete, and etc. For full list of methods, please watch my video. And web API has endpoints. Endpoints is basically API destinations. So you are a weather application. You are a weather application A. And this is a forecast agency. So the different data entry points that you can require the information for example, UK weather, right? We can have a separate Scotland weather. Different points to which you can fetch the data. For example, a forecasting agency might have APIs for Scottish weather, English weather, etc. And the endpoints is the APIs that exist in forecasting agency through which you can fetch the information. So endpoint is the line, is the point, is the address to which you're trying to reach and fetch the information. A simpler example is whenever you're accessing google.com website, google.com is your endpoint, so you're trying to access that website. It operates the web API specifically through request-response model, just as it is any HTTP request. You send the request and you receive the response. So whenever server and user, browser and server operate, that's the model that they use. However, you will often hear that API communication is stateless. And I want you to remember that. I want you to remember that very clearly because this is important. In normal HTTP communication, when we access, from a browser, we access the application, the communication is stateful. Because we access the application, then it might ask us for our authentication details, and the communication communication is persisting, it's stateful. Watch my HTTP video to get more details on that, how the stateful communication works, but the communication is open between browser and the server. And while the TCP connection is open, we're sending several HTTP elements of the web page, which makes this communication stateful. However, when we're talking about stateless communication with API consists all the information that a server needs in order to, let's say, authenticate the user maybe, or any other information that we require to provide. So we create a wraparound, right, request with authentication details or anything else that's needed, and we throw it at the server. There is no stateful connection, it's stateless. Everything we needed, we already sent it to the server in a wraparound, as a present, as a specific box. And then we receive the response from the server, but we don't maintain the state of the application, which removes the overhead, really, removes the overhead of creating the TCP connection, removes the overhead from keeping the persistent connection while sending packets and etc. That's why the API is stateless. Remember that. It's a very common interview question, it's a very common question, and it's important for you to know. It's one of the key advantages that API brings to the table. Speaking of authentication, one of the selling points of APIs was the ability to authenticate using APIs. So in a protected API, you add your username and you add your password and you request something. And then you don't need to authenticate again. That's how we have stateless connection, remember? But you might ask, so in order to fetch something for a weather application from a forecasting agency, do we all have to use our own authentication credentials? No, that's not the case. Most commonly, there are test user accounts that are fake accounts, if you will. And weather agency gives test user accounts to different apps. So for example, Apple app, imagine, has its Apple account. And the API uses the details of that Apple account in order to log in or send requests, fetch information from the weather agency. There are several authentication methods supported by API. The simplest one is API keys that supports the tokens within the API. Another one that is open source, by the way, is oath. It's open source and it came into play because some companies prefer to use this authentication method and they can support SSO using oath. And the third one, popular as well, is JSON Web Tokens. JSON is preferred by some web applications because it's a very lightweight format of the documents, of the files, and therefore JSON, JWT for short, is used as authentication method for APIs as well. This is not too important, but it's good to know which authentication methods API supports, especially if you're working with APIs on a daily basis. Why applications need APIs? Why it became so important that there are API gateways, there are protections for APIs, and etc. etc. Well, API is enabler for your application to again interoperate with other applications, and in other words, to stay in demand. The application that can work, that can integrate with other applications nowadays, can stay in demand better than applications that are more robust and can do that. So it creates interoperability upside for your application. It creates the scalability. Applications that can fetch the information, again, our simple example, weather application and weather agency, right? The application that can fetch information from all weather agencies around the globe, because check on the iPhone, whenever you enter the city name, it can fetch the weather for you. So the applications that can connect using the APIs to different weather agencies around the world, they can scale. They can scale to provide more services for the users, right? It creates the modularity for the applications. I guess this is the point that I raised for the first time in this video, but it doesn't make it any less important. If you watch my video about microservices, you will see that the applications at the moment, they don't like to have monolithic applications. They would like rather to have separate objects within one application. How it works? So in one house, imagine you have different rooms. You have kitchen, you have bathroom, you have bedroom, and these rooms constitute to the house, to your house being cozy, to your house being livable. And each of these rooms have different setting, their own different pattern going on. So the bathroom has a sink, it has a toilet, kitchen has a stove, a refrigerator, bedroom has a bed. Similar with the microservices. So imagine you have Facebook and you have the login, you have Facebook groups, you have Facebook pages and different other objects, different other rooms of the Facebook application. And each team that is working on this specific room, on this specific service, for example, Facebook profiles, Facebook groups, they can write the code in different language. They can design the code in the way they want. What is the most important fact? What is the most important thing in this? Is that these objects can communicate. For example, in the house, the most important thing is that the kitchen, the bathroom, and the bedroom are in the same house, that you can reach them going around the house. And the same for the Facebook. It's very important for these services to communicate, to build together into one application, Facebook. And these small services of the Facebook are called microservices. So modularity ability of APIs makes sure that the microservices of one application can communicate between themselves using APIs. So can you imagine? APIs is not only something that we use with the outer world, it's also something that the application can use internally in order to communicate and establish communications between the microservices. And microservices also can communicate with outer world, with other applications using APIs. So APIs provide the modularity. And of course, reusability. So imagine you have specific lines, right? As a web application, again, we're back to our simple example. In order to fetch the information for the weather in Scotland, you don't have to type the API line on all the time. No. You have certain list of APIs, you have certain list of ready lines, right? You just copy and paste it in your code and the same API will always be fetched. The same information will be fetched. There is no need to reinvent the wheel every single time. It's similar to code blocks. Imagine that you are writing the application, but realistically you're not writing, but you're plagiarizing. You're looking at GitLab, at different applications, and you steal one piece of code here, another piece of code here, there, and etc. And then you copy it into one code. So the similar logic works with API, apart from the fact that you're not plagiarizing. The application, the endpoint, is giving you the API, list of APIs that you can use in your code in order to fetch the information from them. In our example, a weather agency gives the list of APIs to the company. Of course, it exposes the application to API security problems. So some bad actors can try to use APIs not listed by you in order to access resources that are in your application. This is something you need to do extra reading about. We will not be focusing on the API security part of it in this specific video. However, this is something you need to think, because obviously there are bad actors who try to exploit every new invention or innovation in order to make it serve them. So we have interoperability, scalability, modularity, and reusability with APIs. These four are very important points. Remember it, and that's are the major selling point of APIs as opposed to normal stateful requests and responses with HTTP. Now when we discussed APIs, now when you're convinced that APIs are cool, let's talk about the set of rules, the very beginning, right? The set of rules that we have for APIs. Set of rules is basically the protocols that we use, that we agree on in order to enable the APIs. There are four most popular. First, REST. You must have heard REST already. This is the programming interface, the protocol, the framework that is used very commonly for APIs. What are the selling points of REST? REST is lightweight, so it doesn't add much overhead. It uses JSONs, right? And the JSON itself is a lightweight file type. It's very compatible. It's compatible, so it has backward compatibility. So for example, your browser is one version and server supports a higher version. It's not a problem with REST APIs because they are very, very compatible. It has backward compatibility as well. Whereas the SOAP, the second framework that came around earlier than REST, is very robust. SOAP is very robust and it has less compatibility, backward compatibility. There are still some applications that support SOAP in instead of REST, yes, again, it's not as compatible. GraphQL is the API framework that helps you fetch the information from visual contents, fetch the information that you need. It's used in big data analytics, because in big data analytics you might need this specific small piece of data that you need, and it might be hard, and GraphQL web API framework can help you to fetch the exact information that you need. gRPC is newer API framework that is just emerging. It's not used much often. gRPC has been initially developed by Google and it's emerging API standard. The most common application of gRPC is the microservices. It's basically API communication between microservices of the same application. And that's its most common application. However, as we live, we might see that gRPC at some point might become as popular as REST. Let's see. We will not be going into depth of the web APIs because each of them deserves a video of its own. And please comment in the comment section down below the name of the web API framework that you would like me to make a separate video on. Thank you for being with me today and have a nice day. Bye!